is the 2026 F1 engine a cornerstone of engineering? Why change everything when F1 already has the most advanced hybrids in the world? Why? 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 In 2026, Formula One hits a hard reset on how power is made and used. The new rules demand a roughly 50-50 split between internal combustion power and electric power, half engine, half electric, in a car doing over 300 kilometers per hour. Suddenly, engine manufacturers are in a new kind of arms race. That challenge has pulled in fresh heavyweights. Audi entering F1 and a new power unit from Red Bull Powertrains in collaboration with Ford. This isn't just about going faster, it's about redefining what an engine is. So, why this rule change? Because the world outside the racetrack is changing. Engines now need to be more sustainable, more efficient, and more relevant to modern hybrid road cars. F1 wants its power units to mirror the challenges faced by real-world engineers. These 2026 engines will run on 100% sustainable fuels while still delivering extreme performance. At the same time, they ditch one of the most complex, expensive pieces of tech on the car, the MGU-H. Until now, the MGU-H sat on the turbo, recovering energy from exhaust gases. It was brilliant, but insanely complex and very expensive. For 2026, it's gone. In its place, the spotlight moves to the MGU-K, the motor connected to the rear axle. And this is where things get wild. The new MGU-K will deliver up to around 350 kilowatts of power. That's roughly triple the current electrical output. Do you get it? That is a lot of electric punch in a car that already lives at the edge of physics. Another huge change, DRS as we know it, is gone. The rear wing flap that opens on straights, that system disappears. In its place, an overtake mode. Functionally, it aims to keep that extra boost for passing, but instead of flipping a wing, it unleashes extra electric power from the MGU-K. Up to that 350 kilowatts when you're within 1 second of the car ahead. This turns overtaking into an energy management battle. It's not just aero cheat codes anymore. It's about how smartly you deploy your electric reserves. Here's where this becomes a cornerstone of engineering, not just racing. Every piece of this puzzle feeds directly into road car technology. This tech development will benefit new fuel development and sustainable fuel production, power, electronics, and electric motor technology, the mechanics of hybrid systems, high efficiency, energy recovery, and storage systems. Around the world, engineers are searching for alternatives to fossil fuels. When F1 runs on 100% sustainable fuel at insane performance levels, it sends a clear message: this is possible. Now make it scalable. That publicity drives investment, research, and innovation in fuel generation from different sources. Up until 2025, only about 17% of the power in F1's hybrid engines came from the electric motor. In 2026, that jumps to roughly 50%. The sport is forcing itself into a new era. These changes push motorsport toward a genuinely sustainable future. Engines that are still thrilling, loud, and powerful, but powered by a balance of efficient combustion and serious electric drive. But this isn't easy. Carbon-neutral fuels usually behave differently from traditional fuels. They're often harder to vaporize, which makes clean combustion more difficult. So, engineers have two parallel missions: work with fuel manufacturers to create sustainable fuels that vaporize and burn efficiently. Design engines that can handle fuels that don't want to vaporize easily. On the hardware side, a high-output MGU-K changes the car's entire vibration profile. That means teams must redesign and reinforce components to keep reliability under control. And then there's the battery. With huge chunks of energy flowing in and out every lap, you have to minimize performance degradation and manage battery health, all while staying within strict weight and packaging limits. With the MGUH gone, teams also need ultra-efficient energy management strategies that rely on the MGUK alone. That means smarter software, smarter control systems, and smarter drivers. So why call the 2026 F1 engine a cornerstone of engineering? Because it forces solutions to real problems. How to build high-performance hybrids that run on sustainable fuels, how to balance combustion and electric power in extreme environments, how to create tech that can move from the racetrack into everyday cars. But one will prove to the world that you can have mind-bending performance and sustainable fuel. It's not a choice between speed and responsibility anymore. It's a challenge to have both. All this technology will eventually roll into road cars. Better hybrid systems, smarter energy recovery, more efficient fuels, and engines that waste less and deliver more. That's why the 2026 F1 engines are more than just rulebook changes. They're a cornerstone of engineering, pointing toward a sustainable future, where performance, efficiency, and innovation all share the same track. If you want to see how the future of engines is being built, don't just look at road cars. Look at what's coming to the F1 grid in 2026. Like, subscribe and stick around. The next era of F1 engineering is just getting started.